Hello, everyone. Before I start, I'd like to say two things. First thing, organizers asked me to have this black background, so all my presentation will be almost black and white, and just get used to it. And another thing that my presentation is not really technical, so if you're not really familiar with the NLP, it's okay. If you're really a specialist in NLP, I'm sorry, because I'm meeting a lot of technical details, but mostly I'm presenting the approaches that you could use maybe in your projects, maybe you could use even in the same conditions. Okay, let's say this is enough, and a few words about me, why I'm actually here. I have PhD in natural language processing, so I know something about PhD, not really much about NLP, and I have worked. Thank you. I have worked at Yandex and vk.com. Yandex, maybe you heard of. This is like Russian Google. vk.com is Russian Facebook. Here in Russia, we have a lot of our own stuff. This presentation summarizes my experience not only at Huawei, but in other places too. Now I'm in Huawei NOAC ERC Lab, and I'll try to describe to you what is it. Huawei NOAC ERC Lab is approach of Huawei to make like AI products or something. A lot of stuff actually, but what I'm working on exactly, this is this vertical stuff like dialog systems mostly, and this exact presentation is about what we call the domain adaptation. I'll explain in more details later. If you do not know these words, it's not really important. So first of all, why we actually doing this? The dialog systems is really useful when you're trying to talk to people. I think it's pretty much obvious in 2019, but it is not only obvious in 2019, but it was obvious like 5 years ago. And since that, we have a lot of dialog systems in the wild. Maybe you heard of Alexa from Amazon, really great product. Google Echo, and so on. A lot of products which are dialog systems, and we actually want to do a dialog system also. Okay. What is dialog system? I'm actually saying that there is a dialog system, and what is it? Dialog system itself is actually consists of four main parts. The main part is a user. Of course, this is why we're actually doing something. This is there are people which are working with, there are people who are using the dialog system. Next part, this is natural language understanding, and this is like what I'm will be concentration in this talk. After that, the data from natural language understanding. I'll come back to this in the next slide, so just keep it for now. The next thing is this management, is dialog management, where we actually choosing what to do, how to answer a user. And this is important that this is how, not what we're actually saying. What we're actually saying is the next part, which is natural language generation. Okay, but as I was saying, this is not really important, the other parts. The part which is important is this is natural language understanding. And what is actually going on here? Here we have I see, this is really tricky. So here we have a phrase from a user who actually wanted to see some movie. And we need to extract this information, and we need to have some representation of this information for the further needs. So as you can see, the output is somewhat structured here. What means somewhat structured? Let's try to discuss this. This thing is a really classical one. I think it comes from 1970s. And what is this about? This is about so-called ontologies. How many of you have heard this word? Ontology. Some, as far as I can see. Ontology is a really simple thing that if you ever studied in school the biology, you heard of this thing as species. You heard of like more global things like animals, I don't know, mushrooms and so on. This is like kingdoms in the biology, and all of these things are interconnected with each other in like this tree-like structure. And this tree-like structure is an example of an ontology. And here we have also an ontology, and like in the biology, but of course not so much, but it requires a knowledge from the domain. I'm saying domain, and what I mean by domain. Domain is anything that we actually working with. For example, if we're saying that there is a bank which want to sold a product like, I don't know, maybe some product from bank like credit or something, this is one domain. Another domain, like in this example, this is a restaurant. And in restaurant domain, we have some specific needs, like we want to know where is the restaurant is situated, where is the restaurant, which cuisine is a restaurant serves, and how pricey it is. So this is, there are three main things in this domain. In other domains, there should be other things, but this is important for this specific domain. So the idea here is like we have this example. Find a cheap Taiwanese restaurant, and we want to extract some information from it. So we know, as a human, we know that the restaurant should be cheap, so the price range is cheap. The type is Taiwanese, and the location is city center or something. It's not important. The important thing that we have unstructured information as input, and the structured information as output. And the structure is in here is the so-called semantic frame representation. What should I also add? That these semantic frames are really different for some domains. So if we have different domains in our dialog system, then semantic frames should be interchanged during the dialog. And this is some kind of an issue, and I will discuss it a little bit later. Okay, next thing that what is the slot? The semantic frame represents an information in the domain in this structured kind, structured type. But we actually have no structure in the input text. We need somehow to extract it. So the process of the extraction could be divided in two steps. The first step is so-called slot recognition, or is more generally, maybe you're most familiar with named entity recognition, where we have these things. We have some words which are not important for this specific task, which are really like something other. And we have some words which are important. They Here they represented by tags B price, B area, and so on. So the idea here that we have some markup which is marking the words in the sentence. But this is only the first part. The second part is also really important, and it could be more difficult than the first part. I explain how. The idea here is that if we have this cheap price and we know that there is like price cheap in our representation, in our vocabulary, then everything is nice. But if we have another word like expensive in our vocabulary, and user says that she wants a pricey restaurant. Pricey is a really colloquial thing. It could not be in our vocabulary. And we should somehow handle this situation. So this is why I am saying that could be really important. So the first step was like we recognized words which are essentially the candidates for some slots, for some structure to extract from there. And the next thing is actual matching from this unstructured information to the structured one. Okay, so this is one thing that is done by natural language understanding, what I was talking about. Another thing is so-called intent classification. Intent classification is when we want to understand what our user actually wants. Like if we have this phrase about the Taiwanese restaurant as before, we should understand this is not about the movies, it's about the restaurant. And this is when we actually need our multiple semantic frames. As far as we remember, we could have multiple of them, and we should switch them if we detect that this intent is not the intent the user wants. Of course, this is like not exactly what the user wants. This is how we understand what he or she wants. Okay, so this is how we actually extracting the intent classification. Okay. As I said, this is the whole task is natural language understanding, and of course it has been solved in a way that it could be solved earlier. Of course, there are some types of things that have already been done there, and I will describe you a few of them because they are really important, really simple, and really powerful. Still powerful. Maybe in not this particular application, but generally they do. And you understand why I'm choosing only these. Okay, so first conventional approach that I like to share with you is so-called TF-IDF. TF is term frequency, IDF is inverse document frequency. What is it actually? The term frequency itself is how often this term or word for simplicity is how often this word is used in this particular document. So we have this hypothesis that more we use this word in this particular document, then more important it is for this document. This is just a hypothesis, but it is really good in practice. Another part is that how often this particular word is could be found in this corpus. The corpus is multiple documents, so if we have a lot of documents with the same word in them, that we could conclude that this word is unimportant. this word is really common, and we have no need in this word. Like a lot of words which in practice called stop words, like I don't know, the verbs, maybe some verbs like is, are, something like this. They are even important because they have no, you have almost no document without them, and you could skip them easily. And you should try this technique because it is really simple and it could be applied to any corpus. You have no need in any markup there. This is just input and output, and you already could use it for some, for example, for comparison of the documents between themselves. And it actually works. Another thing that I want to discuss with you is Word2Vec. Here in the morning was Tomasz Mikolev, who is the inventor of Word2Vec, and I'd like to say that I'm thankful for him for the invention of this thing, and you should be too if you're in NLP, because what the Word2Vec essentially? The Word2Vec essentially is a way to represent a word and to represent its semantic qualities, some features, semantic features. And as you can see, these semantic features could be useful. Like here in the example from the original paper, they have the connection between a country and its capital. So the idea here is that you could train a Word2Vec, which is also unsupervised, on any corpus, and you have useful features right out of the box, right out of the model. Okay. This is things, and this is the problem I try to discuss with you. The classical dialog system problem is not the same. The idea of this specific problem is that we need to do natural language understanding on almost unseen data. So we have almost no data for the process, for processing. And what is exactly this? We need to detect a slot, and we need to get a value of it. So you already know what is the slot detection, and you know what is the value extraction here. And the idea is that the main issue here is that we haven't seen our data. It is almost, but it is still really hard. So the complications, how the tasks is formulated. So we have 200 different slots. We have 14 domains, like bank, like, I don't know, some alarm maybe, some, I don't know what exactly, restaurant, movies, so on. We have 15 skills per domain, and we have only one sentence of the description. What is the sentence of the description? As I was saying, this is like, for example, in this restaurant domain, we have location slot. And location slot has a description, a place where the restaurant is situated. Something like this. It's maybe, this is example from just from my head. And the idea here is that this is really could be not enough. How can we actually use it? Let's start what have we done. First of all, we have applied BERT. BERT is really great. It is using the context, and the usage of context is really important. It's like really essential is many of the tasks. And after that, we have used, we fed this output of a BERT, these word vectors, which is exactly not exactly word vectors in the sense of word-awake, but this is not important. And we fed it to RNN. And after that, we have used some special tricks I'll be discussing in a few slides. And after that, we have some profit. Okay. First of all, I need to discuss with you what the RNN is. The RNN is a recurrent neural network. It is a really simple to understand thing. There will be no any formulas, so you could like not be sleeping right now. There are no formulas, only pictures. And the idea of RNN is really simple. Like we have some input, we store some of the representation of this input inside the model. And after we're actually feeding the next input, we have already some knowledge from the previous step. So this is RNN in a nutshell. So on the left, there is a picture of RNN. On the right is just the representation how the information flow here is done. Okay, I hope that the idea of RNN is understandable now. The next thing is BERT. I will not be discussing with you how the BERT is really done, but the important thing that BERT is actually using all the context. So it is using the previous context, the next context, and so on. So we have a word as the input here, and we have some vectors as the output. But unfortunately, I couldn't skip the detail of BERT training because I need to explain how we actually, what tricks have been done. So there is like this positional and embedding. This is a thing that not really important right now. This is just representation of the position of a word in like a sentence. So it's first word, then it's one embedding, second word, another embedding, and they're not depending on the words themselves, only on the position. Next thing is sentence embedding. So if we have the whole sentence, we have the embedding for it, and we use it to represent a word. So this is like a context for a word. And the token embedding, this is the finally token embedding. It could be word-awake, could be something else. So token embedding, sentence embedding for the context, and the position embedding to understand where this word is actually are. And the tricky part here is this CLS token. There is other tricky parts, but this is important. The CLS token here is what we actually doing with BERT. Like we teaching BERT to use the CLS token for the prediction. So we force it to predict if this word is somewhat like, is it the next sentence or is it like this word we want to know. So we use this special CLS token, is from classification for sure. And finally, tricks, what we actually doing. So the first thing is really simple. We have this CLS token. I was talking like a few moments ago. A lot of words afterward. And we use the embedding of a sentence. This is a sentence representation here. And we use this embedding for the CLS token as the embedding of the whole sentence. And this is true because, as you remember, maybe, BERT is really context dependent. It's depending on the whole context. Okay, this is one thing. Another thing, this is so-called comparison. I am not showing you here the formula. I think I'll share it later. But the idea that we have two embeddings of a sentence, which we are actually working right now. This is utterance from our user. And this is a description embedding. So as you remember, there is a description for a slot. And we use it to compare the sentence embedding and description embedding. Okay, another thing that we're using, as I was saying, that this is at the bottom, these are an embeddings for the utterances in dialog. So this is one sentence, another sentence, next sentence, so on. And we feed it to the RNN, which is actually producing some additional processing of these embeddings. And this is outputting the processed embeddings. And we use these embeddings to actually have some conclusions there. So to have slot slot recognition, we have embedded all our words in a sentence, for example, and embedded it through RNN and use it as a comparison here with this slot description, and we're producing the markup for the slot. So as you remember, we need a markup to extract its data. So we have embedding for the sentence, we have embedding for the slot description, and we use it with comparison to produce the actual markup. Okay, so we have produced the actual markup. We have produced some CLS token embedding to have the classification. In our case, this is intent classification. And what is actually it? Yes, it's actually it. And what we have done, we have what we're measuring here. We're measuring the accuracy of slot detection and the intent classification. And with first approaches I was describing to you with this TF-IDF, we have only 15% of this metric. After that, we have applied GLOVE, and it gives us 40%. And all of this tricky engineering that I was describing to you, it gives us 80%. So I think this is worth trying, at least. And let me formulate the main takeaways from here. Main takeaway is try the simple things because they are still working, and this is really good to have them in your vocabulary. Try well-known things like this word2vec, and this is also good to know. And also try the things which are popular. Maybe they're popular for a reason, like in our case. So this is actually it. And this is my context. If you want to contact me, also you could come to speak with me is AMA Corner. And I'd like to ask one thing that for some unknown reason, we have right now the product that should be done in Polish language. And if you're special in Polish NLP, please come and speak with me. I'll be happy to have known you. So thank you. Thank you for your attention.